All right. Hey everyone, welcome to the Just a Lab. I am Just Baron, and on this channel, I do just about anything you can do yourself. On this episode of Fix It Fridays, I'm going to be doing some hands-on battery repair. I actually have ready. Oh, yeah. So I have some of these V-mount batteries. A buddy of mine who's actually a professional videographer. Should I say his name? Shout out Flex. He has a couple of these batteries that stop working. They're lithium ion, pretty cool, really big, like 98 watt hours. Apparently, you use these for like camera gear and stuff. I wouldn't know about this. It's not like I just do like video editing, video recording, or YouTube videos. But yeah, he came and dropped off some of these batteries for me. Told me this no longer working and check to see if I can fix them. When professionals start to request you to fix stuff, I guess that's when you need it. Started from the bottom, now we're here. I don't know. So today's video is all about opening up these, seeing how they look on the inside, and seeing if I can fix them. That being said, cue intro. So I have the batteries here. It's three batteries. One is 150 watt hours. The other two are 98 watt hours. And I kind of understand why Plex wants these fixed so badly because this shit's expensive. Like, it's like 230 US for one of these. Like, damn. I was like the cost of my whole camera video setup here. They're apparently really important for camera gear and stuff. So what I want to do now is I want to open up a couple of these and see what's inside. One thing I can notice here is, you see on this one here, when you press this little light button, it lights up slightly, right? This one here also does the exact same thing. There's a little bit of light there, which means it has a little bit of juice in it. Not sure if the camera is picking it up. But this one doesn't do nothing. It's like either really, really dead. I was able to get some specifications for these devices. You can get the direct power out for them right here. So let's take a multimeter, just check it before we do anything further. Kaiweets multimeter, link in the description for discount code. Just to keep track of batteries, I'm going to write some labels on them. This one here is going to be battery number 1. This is going to be battery number 2. And this is going to be battery number 3. Let's check battery number 1 first, right? So battery number 1, they actually have some pinouts at the bottom here, and they have the plus or minus. I'm not sure what the middle ones does, but I guess it's irrelevant. But if I put positive and negative in, I'm getting 9.6 volts, which is pretty low compared to the 14.8 it's supposed to be at. Well, at least around there. If I look at the other one, 10.10 volts, which I guess is 4 volts less. Seems like it's a cell less. And this big bad boy here, let's see what he says. Oh, he's giving nothing, like nothing whatsoever. Looks like he's in a high impedance kind of output. So I guess we could save this one for last because it's gonna be hot. I guess the next step now is open up these batteries, see what the inside looks. Right. So, all right, cool. So as expected, we have a battery management system here. We have LED lights lighting up there. USB port here, the side here that just has like voltage in. We have a power supply here, I guess. Okay, so cool stuff. Can this come out? Okay. Cool. So this whole thing comes off. This is a normal battery management system. We have power and charge on the same line. No surprise there. And this is temperature here. And the other two actually does nothing. So, okay. Looking inside of here, you can see it has some contacts. This board here is a battery management system. 4S battery. So you have between B positive and B3 is one cell. B3, B2 is an X cell. B2, B1 is a cell. And then B1 to B negative or B0 is another cell. And you can see kind of like by looking on top here, you can see it's like 2 banks here. So it's 3 batteries make 1 cell. If I measure the voltage between B positive and B3, or at least B4 and B3, I get 3.8 volts, which is a good voltage for a cell. Cells shouldn't be under 3 volts. 3.3 is a normal for lithium polymers, or in this case, lithium ion batteries. P3, B3, and B2, we actually get 0 volts. So that's a bad cell there. Between B2 and B1, we get 3.6 volts. So that checks out. Between B1 and B0, we get 3.8 volts. So that checks out. So right now, I can tell that one of these cells here, or at least 3 of these batteries here, are considered bad. So that'll be an easy replacement. So let's put this stuff back in the corner here. Let's see. I suspect there's a similar problem on the other side. So let's check battery number 2. We're going to do B positive to B3. And we're getting 3.8 volts, which is good. B3 to B2, we get 3.8 volts, which is good. And we're doing B2 to B1. We have one bad cell here. And then B1 to ground, we have we have a good cell here also. Okay, both of these have one bad cell each. It's interesting that both of these battery packs have one bad cell, and one bad cell is made out of 3 batteries, and they're all in series. Each cell is individually balanced, and that's why I guess this is not giving me correct. This is not even working, because what happens is the battery management system is probably realizing, hey, what, there's a bad cell. I'm not going to charge, or I'm not going to operate how I supposed to. It's still going to output a voltage. So what I think is, I can actually take one cell out of this pack here and put it in this pack here. The thing about it is, I want to have uniform batteries, and what I can do is I can actually build a whole new pack for this, because I have a box of these. Crap! I have a box of these cells here. These are 2,600 milliamp hours compared to these, which are so these will be 6,800 milliamp hours divided by 3, which is what? 3 into 6 is 2. 2 into 8 is, sorry, 3 into 6 is 2. 3 into 8 is how much, boy? Alright, so these batteries are going to be about 2,200 milliamp hours. Even though I don't see it marked anywhere. While these are actually going to be 2,600 milliamp hours. So these are actually much more powerful than these. But I obviously can't group these up with this. So I also have spot welds that I want to try out in this video. I actually got this a while ago, probably like last 6 months ago or something like that. Hopefully I'm going to use that today. Never used it before, so we'll see how that works. And yeah, so I guess the main thing, the first thing to do is remove bad cells from each and replace one of the cells back there to see if we can get proper charging and stuff for it. Alright, so the idea now is this needs to somehow go inside of here. Like a piece of Tetris.
20 minutes later. 6 hours later.
Right, so that drops in there like that. And I need to somehow weld these other pieces together now. Okay, just to get a proper summary right now. So right now I actually have the new cell in. It's not like solid yet or anything. Actually, I could solder this. I actually don't even need to use a spot welder at this point, because it's so easy to solder this. To solder this together, I'm going to do a join on top to the other cell, and then I also need to do a join at the bottom to the bottom cell. So how this works is you just put it on.
Ooh, shine.
I'm not sure why it's not coming on, but you just put it on. This button. Oh, these are spot welders. Let's try to do a cross piece. So I'm gonna just take two pieces and put them on top of each other and see if they weld together. And I do a thing like this. Look at that. That's like stuck together. What I'm gonna do is I'm just dropping that little piece of metal one there and another one up in the back. All right, everyone, so I'm not sure if you guys can see this, but if you see some bad spot welds there, those are the ones I just did. And the last thing to do now would be to do the bottom side, which will get a better view on the camera. So let's just cover everything back here. So let's flip over to the bottom. Trying to be as careful as I can. Alright, so I need to solder on top of here. So what I am going to do is I'm going to clean up some of these edges like I did last time. These scissors. Or metal. And I'm going to just measure out some pieces. Right. So we need to do one across here. And we need to do one coming down here. Gonna take the spot welder. 1 and 2. 3 and 4. So cool. 1 and 2. And then 3 and 4. Good. And I'm also going to add a little bit of solder to join this here. Now a disclaimer here is actually, like, I realized I actually don't need this, by the way. This is like just overkill. You can actually solder this and it should be just as fine and just as good. But obviously, so this is much neater. The last thing to do now is just to solder the top of this jack here. So it's just to lip that over and solder that there. And this battery should be good. Okay guys, so after just fixing this one battery already, you can see that if I press this button here, I'm not sure if you've seen that, but all the lights are lighting up on the charger. So if I take my multimeter, B positive to B3, we're getting 3.8 volts. B3 to B2, 3.8 volts. B2 to B1, 3.69 volts. So we'll charge up when the battery charge with the balance charger. And then we have B1 to B0, 3.8 volts. And then if we look at the total output, we have 15.14 volt. This means this battery pack here is done, and I can package this up and put it back in the box. Yes, there's a little bit of ripping and stuff on the material and stuff, but guess what? All that stuff doesn't really matter that much. Once it's insulated, once it's not touching anything else, everything should be pretty good and pretty fine, right? I can put this back. This is what number 1. I can put number 1 back in its box. Number 1. This needs to go down first. Do some wire management here. So this goes out here. USB runs underneath. I think that's it there. Battery lights line up. And put our cable in, and then our USB port can go in. Yep. So let's screw in our USB port also one time. Good. 2. Alright, so that's one battery down, one more to go. Alright, so this battery here is working and good. You can see all the lights are here, and according to my multimeter, if I put positive and negative here, it's giving me 15 volts, which is way above what it's above what the nominal is supposed to be, which means it's working. And what I can do is, according to the specifications, the charging specifications, I can actually charge this from my bench power supply, because all the charging circuitry is built into the battery management system. So if I was to take my multimeter now, charging, it's supposed to, you have to use a 16.8 volts, at least 2.5 amp charger. Put these on the charging pins. Well, the power pins and the charge pins are the exact same. So I should be able to just put this here and clip this here like this. It's outputting onto this 15.11 volts, but if I was to put this on, I am charging right now at 2.5 amps, right? So I should be able to just leave this here, and it would be charging in the interim. And I guess hopefully it doesn't explode. As that is charging there, I think I'm going to call this video at this point in time. The other battery is going to be almost the exact same fix, except I'm actually going to be building the battery pack this time. I don't know if you guys will be interested in that. I'm probably going to just record it, but I don't know if I'm going to actually put it in this video. But I think by now you guys have a gist of how easy it is to fix these batteries. I am not sure what is wrong with that big one yet. That may be a video by itself. I don't know, but we would see. Also, when dealing up with these batteries and stuff, you want to make sure and use the same type of battery, because any current draw from each cell might be different when you're using it. Alright everyone, that's a wrap to today's video. I hope you liked and enjoyed it. If you look behind me right here, there's a light lighting up, and this is being powered by one of the batteries that I fixed. You can see here. I don't actually have one of the official V-mount lights or camera gear that actually supposed to go with that, because I'm not a professional videographer. But the battery does work. I have the other one that I fixed charging up right now. That should be there a while. I still have the third one, which I don't know what is wrong with it. I didn't dive into it because it's getting late and running out of time and stuff. I have other things to do. But I hope you guys appreciate the repair process, the figuring out what's going on, doing something sketchy, realizing the sketchy thing worked. And this video is probably going to be all over the place, just because I was just rambling on and stuff as I go along. But if you do like this kind of content, and if you do like this video, hit that like button, helps with that YouTube algorithm. If you like this kind of content, do consider hitting that subscribe button. And if you think I did something way too sketchy, or if you think there's a better way to do things, or just general comments about the video, do let me know in the comment section below. And again, that wraps up Fix It Fridays. I hope to see you in the next one if I keep up this level of consistency. And yeah, that's about it. So camera batteries fixed. Yeah, cheers.